Hello again. In this video we will talk about vectors and scalars and some basic math, vectorial math, right? Math for vectors. Let's go with this. Remember that when you have a scalar, all you need is the magnitude, like temperature, for instance. But when you have a vector, on top of the magnitude or next to the magnitude, you also need a direction, like displacement. That's an example. To differentiate between scalars and vectors, we, when representing a scalar, we only use like a letter, right? Like letter A. This will be a scalar, like let's say area. But if you had a vector A, what you would do is, in a lot of the books and in our book, they put an arrow like this. In some books, they just put a line, not necessarily an arrow. In some books, they just do like bold A, and that tells you that's a vector. So either of these three, you will see in the book, and you will from now on, you will see me putting a line or an arrow on top of a letter or symbol to represent that we are talking about a vector. Similarly, if you want to represent the magnitude of the vector, then you can do this. You put the little two lines for absolute value, and then that means we're talking about just the scalar, well, the magnitude of the vector, which is a scalar. So now let's do some basic vector arithmetics. For two vectors to be the same, for vector A to be the same as vector B, both the magnitude and the direction need to be the same, right? So they must be equal arrows, right? A and B, they have same magnitude, they have same direction, and now you can say, yes, they're equal. If only the magnitude or only the direction are the same, then we cannot say that the two vectors are equal. Notice that the starting point and end points are not important. If we have vector A and B in the space like this, as long as they have the same magnitude and the same direction, they're still equal, regardless of way they start or way they end. Okay, so now let's take two vectors. Vector A is going to be, let's say, this, okay? And vector B is going to be this, right? Clearly not the same. But what if I want to add them? What if I want to do A plus B equals C? First of all, if this is a vectorial addition, if you write this is not a vectorial addition. This is just scalars. You're adding scalars. But if you have to add vectors, then you have to follow very precise rules. Let's add these two vectors, and the first I'm going to show you how to, or remind you how to add them geometrically or graphically. So to add vector A plus B, we're not doing this. We're going to do this one. So we're going to do the graphical method, and first thing we need is a coordinate system, X and Y. So to add A plus B, the first thing you do is you draw vector A, which I'm going to try. Let's say this is vector A. Of course, the best thing to do is to use a ruler and a protractor, and then you plot, or you draw your vector A, and then where vector A ends, you will plot a vector B. Now this is B, and then what you do is you connect the beginning of A with the end of B, and that is vector C. And I forgot the little lines everywhere, but these are all vectors. That's how you add two vectors graphically. Now, let's say you also have a vector d that looks like this. So if you have to add a plus b plus d equal f or whatever, well, we do the coordinate system. So we plot a, I'm going to use the same color now. A, this will be A, let's say. Of course, you measure it properly with your ruler, your protractor and everything. And then you put B, and then we put D, well measured and everything. And then that means this will be F. And now let's take a look at this. Let's go back with a simple A plus B, which we did here. A plus B, this was A plus B equals C. So what happens if we do B plus A? So let's see what we get. So I'm going to plot my X and my Y. So if I have to do B plus A, that means I plot B first, which we can see it's like this, right here. And then where B ends, I'm going to plot A, which looks more like this. No, A. So C will be this vector here. And basically this C that I drew here is the same as the other C that I drew there. Because we can do this, look, if I do A plus B equals C is the same as B plus A. You see, we get the same result. So that means B plus A is the same as A plus B. This is called the commutative law of addition. Now let's consider these three vectors, A, B, and C. What happens if I add A plus B plus C? Let's do that. Okay, X and Y. So first I'm going to plot A. So A is here. What would be B plus C? Well, let's say if this is B, C, and then this is C, I don't know. See, this is C, so I'm adding C to B. You see this? Oh boy, this is so difficult with this tab. This line here, that will be B plus C. Yeah, right? You agree? So what would be this line? Well, that will be A plus B plus C. And then parenthesis here. Yeah, do you agree? Can you see that A plus parenthesis B plus C will be equal to A plus B plus C? Like if I follow this path, it's simply A plus B plus C, and then we get to the same end. And then I connect from this beginning to here. So it's exactly the same thing. I also could do A plus B. If I did A plus B, which will give us this line, you see A plus B, and then I add C, I end up at the same position. So that means these three are the same. And this is the associative law of addition. Now consider these two vectors, A and B. If this is A, you recognize that if I add or I subtract A minus A, this should give me 0. So what will be the only way for this to happen? It will be to put A like this and then to add the same vector, but in a different, in the completely opposite direction. That will bring me back to 0, right? So that means this vector here, that's negative a. So how do you make the negative of a vector? Just reverse the direction by 180 degrees, right? So if this is b, minus b will be just the opposite. Same magnitude, but opposite direction. This was b here. So this is 180 degrees and gives you minus b. So how do you do then a minus b? How do you subtract two vectors? Well, basically you do a plus the negative of b. So let's do a minus b using these two vectors. So first we plot x and y, and then let's do I will do a, that's a, and then if I were to do plus b, you see I will put b here, right? That will be my b, and then this here, this will be a plus b. But I don't want to add b, I want to subtract b. So I'm going to plot b in the opposite direction. That's minus b. So then this vector here, that's a minus b. Let's say a minus b equals c. So that will be your vector c from here to here. That's a minus b. We're going to do an example in class, and but this is the end of this video.